Welcome to your first instructional video for Pre-Calculus 11.0. This video is going to be our first video in the quadratic unit. Before I get into that video, I'd like to go through some of the expectations that will fall upon students as they use these instructional videos. First thing is you have to realize that these videos are not something you can just watch like a television program and then when the show is done, presto, you will understand and know everything. It's very unlikely that that's going to be the case. You're probably going to have to watch these videos multiple times. I suggest you have the slides, the blank slides ready in front of you so that you can use those slides, take notes, pause the video as it's being played. If you come to an example, pause it, try the example, then play the video, see how you made out. Pause the video again, rewind the video, whatever it is going to take for you to understand the material. But for the majority of the students, that will be much, much more than just watching this video once and thinking that that's going to be enough to make sure you understand the material. All right, so let's get to it. Our first section is an overview of the properties of quadratic functions. You have had a brief introduction to quadratic functions in the past. However, it may be somewhat limited, so we are going to pretty much assume that you have no idea what a quadratic function actually is. So if you look here, I just have some pictures and terms here. The first term you're going to come up with or hear tell of is a parabola. So a parabola is a graph that is shaped like the letter U. They may open down or they may open up. We will not get into ones opening right or left. We'll save that for your grade 12 year when you hit calculus. We will discuss them at that point. We'll talk about these, and again, don't worry too much about that. We'll talk about all of this in more detail later on. This is just kind of a slide showing you some of the terms and things you're going to use. So these parabolas may have a high point, which we'll refer to as the maximum. They may have a low point down here, which would be the minimum if it opened up. In either case, that point is something we call the vertex. So that will be a very critical value when dealing with quadratic functions. We'll talk about symmetry. We'll talk about an axis of symmetry. The pictures that you see here are just some schematics of parabolas in action. So there's actually a bridge that's built with a parabolic arch. These are the fountains, I believe, from Las Vegas. These are the ones that shoot out into a parabolic fashion. These are parabolas, one opening up, one opening down. We'll talk about domain, range, intercepts, and a variety of other things as well. But this is just kind of a slide to throw some things at you to say, oh yes, I heard tell of this, I heard tell of that, or vice versa. Okay, this is from your textbook, and this would be an outline of some key terms. And again, I'm never going to ask you to write out the definition of terms, but what I might ask you or expect of you is that if I say, well, look at the vertex, that you know what I'm talking about. If I say, well, where's the axis of symmetry on that quadratic? You would know what I'm referring to. First thing that starts out is a quadratic function. What is it? Well, it's a polynomial of degree 2. So this term right here, degree, may be something you're not familiar with. I'm just going to quickly talk about it over here. It's nothing too exciting, but this is what it means. If I had y equals x squared, this would be degree 2. Now you say why? Well, you can probably guess why. It has to do with this exponent. Degree refers to the highest exponent that is present on any of the variables, sort of. I'm going to elaborate on that in a second. I'll just give you another example. Let's say I had y equals 3x to the 7th minus 2x to the 4th plus x to the 3rd minus 4. Well, this would be an example of a degree 7 polynomial. You say, why is it degree 7? Well, it's degree 7 because the highest exponent that I see anywhere here is a 7, which makes it a 7th degree polynomial. Now that's pretty much it, but the only reason I said I'm going to have to elaborate on this a little bit is if you get multiple variables on the go, so let's suppose I had y equals 3x cubed y to the 7th plus 7x to the 8th y to the 5th. Well, one might look at this and say it's degree 8, and based on what I told you up here, you'd probably be headed in the right direction. Well, unfortunately, it's a little bit different when you have multiple variables. This one, you take the two exponents and you add them. So that would be a 10. These two, it would be a 13. So in fact, this would actually be degree 13. Now, not something that's overly important. However, if you're going to study any kind of mathematics at a pre-calculus and calculus level, it is a term you should be familiar with. So a quadratic is a degree 2 polynomial. For example, in its most basic form, f of x equals y squared, or just y equals x squared would be what we refer to as our base parabola. I have a sketch of that here coming up on one of my next slides. It's a symmetrical curve, so if you look at all that means is it's symmetrical about a line, and in this case, this would be what I refer to as my axis of symmetry, which in the parabolas we're going to study is always going to be a vertical line, so this would be my axis of symmetry. It is the line that basically cuts the parabola in half, so that the right side, this point, and the left side are mirror images of each other. That's what symmetry means. So essentially, if this was a mirror, the right side would be reflected over on the left side, or in this case, vice versa. This one here, this would be my axis of symmetry. Sometimes we'll just go AOS, axis of symmetry. Same as writing it all out. Our vertex is either that lowest point of our quadratic function, or if it opens down, it's that highest point. It's basically where it's the one point where you don't have your symmetry, because there's no reflection at that very one point where our line of symmetry passes through. All right, so those are just some of the terms. Axis of symmetry, we'll just talk a little bit more about that. It's always going to be a vertical line, as I said. As you worked your way through Foundations 11 and Nerve 10, you would have at some point talked about equations of lines. In fact, even in grade 9, they talk about these. Anytime you have a vertical line, the equation of any vertical line, so my question I would have asked if we were sitting in the classroom, I would say, well, how do you describe vertical lines properly using correct math notation? Well, to describe a vertical line that's cutting through 3 on the x-axis, it would be described as x equals 3. So if I said to you, what's the axis of symmetry of this graph? Now, unfortunately, I will sometimes get students say, oh, it's 3. I'll say, oh, you're close, but I want you to use proper notation. The number 3 doesn't describe a line. It's just a number. I want this vertical line, so it would be x equals 3. Really, really important that you use proper notation. So if I have a chart that says identify the equation of the axis of symmetry in the following quadratic, and you just write 3, I'm going to probably take off half a point or something. All right, so make sure you're using correct notation. Any vertical line is x equals the number that it passes through. All right, well, here he is. The most famous quadratic of all is the base parabola called y equals x squared. It is referred to as the base parabola. We should be able to identify some ordered pairs that are on this. We should be able to do it by looking at the graph. We should be able to do it by figuring them out as well. So let's take 0, for example. If x is 0, what's the y coordinate? Well, the y coordinate down here would also be 0. If I go over 1 and go up to the graph, I hit the graph at this ordered pair, 1, 1. So when x is 1, the y is 1. If I go over here to 2, follow up, follow up, follow up, hit the graph right there. Well, hopefully you're not surprised when you see that when x is 2, y is 4. Now you may be saying, well, that's easy. I know how to read points off a graph. But you shouldn't have needed the graph because your function or your equation that we're using is y equals x squared. So remember table of values, how they work. If I say x is 2, well, you put x is 2 in here and you square it, you're going to get the y coordinate. So 2 squared would be 4. Well, without you being able to see, what do you think it is for 3? Hopefully you're thinking, well, it's got to be 9. Yes, it is. If you go over this way, -1, well, if you put -1 in here and square it, you're still going to get 1. If you put -2 in here and square it, you're still going to get 4. So these are what we would refer to as our base points off of this basic parabola y equals x squared. And what we're going to learn to do is take this base quadratic function that you see here, and we're going to learn how to transform it. We're going to apply some transformations. We're going to identify, well, how do I know whether it's going to open up or down? How do I know whether it's going to move left or right or up or down or any of this kind of information? And what we're going to do to kind of play around with that a little bit is I'm going to use a piece of technology referred to or known as Desmos. I strongly encourage you to, on your mobile device, I'm assuming most of you, if not all of you, are using some sort of a phone, whether it's an Android phone or an Apple phone. There is a app called Desmos, which I would recommend you put on your phone and have it there to give you a really powerful graphing, and it'll do some neat things with calculus and some calculations. All right, so as I go down here to my web browser, open up, and I'm just going to type in here www.desmos.com. It's going to open up this window. You're going to just select graphing calculator right here, and you should be into the graphing app, which looks like what you see in front of you. Okay, so we're going to start with the base parabola, and we're going to go through what are called transformations, and we're going to try and kind of get our head wrapped around what happens when we put certain numbers in certain locations in a quadratic function. All right, so there's your base parabola, y equals x squared. Let's just go look at it real quick. So you'll notice here that if we go over, so this is 2, so if we go over 1, because every block's a half here, there's 4 blocks from 0 to 2. So over 1, we're going up 1. Over 2, we're going up 4. If we went over 4, based on the fact that this is y equals x squared, this should be hitting the graph up here way up at 16. We can't see that. I could if I zoomed in, but we're just going to leave it as it is for now. Okay, so the first thing I want to look at is how could I make that parabola turn over, open down instead of up? So if you think about it, what I would want to have happen is I would want these numbers to end up down here. Well, right now, all these y values, these your y values, are positive numbers. Well, I just said that for it to turn down this way, I'd want all the y values to be negative numbers. So to do that, what I would do is take my function, and I would want it to be y equals negative x squared. Let's have a look at this, see what happens. And just by the way, as I'm typing this in, if you're curious as to how you're doing those exponents, right above the number 6 is your up cap. So if you just go shift and that button, it'll give you your option to put it as an exponent. For fractions, we'll get into fractions here in a bit. Just use your little slash sign, like a division sign. It's right below the question mark on your keyboard. Okay, so look what happened. It did in fact turn over and open down, which again, as I kind of explained it, hopefully you understand why that happened, because what I did is I made all the y values become negatives, because I took the negative of what they were up here. To get the y values here, I was squaring the x's. Well, here I'm still squaring the x's, but then I'm going to take the negative of my answer, which turned them all down here. So that's the first thing I want you to notice about quadratics. If you want them to open down, you're going to have a negative out in front of your x squared. All right, that's the first transformation. We've got 4 of these to look at. The next transformation we're going to look at is how to take your base parabola and either open it wider or narrower. So I'm just going to type in here y equals 2x squared. Now notice what happened. It got narrower. Now, I probably should have hesitated for a second, let you think about it, so it didn't automatically pop on the screen like that. But now let's see if we can figure out, why did that happen? So I want you to think about what happened. This was going to take all the y values, which were originally x squareds, and it's going to double the x squareds, which means it's going to make all the y values twice as big as they were before. So if we take this one, for example, on the red graph, which is your base parabola, when x was 1, y was 1. Well, by putting a 2 in front of it, when x is 1, the x isn't going to change, but the y value is going to be up at 2. So it kind of pulled that point up into here. We call it a stretch factor. It stretched our parabola vertically and made it narrower. Well, if I said, let's put another one. Let's leave that one there. Let's put y equals, let's put 9x squared. What do you think is going to happen before I hit the enter key here? So I'm going to put 9x squared. In your head, say, I think this is going to happen. And then let's have a look. 9x, let's put this. Look at that. So you can see that it got even narrower. Actually, why don't I just back it up a little bit so I can see it on the grid without having to zoom it. You can zoom. There's a zoom over here. See over here on the right? You can zoom in and out. Oh, maybe I'll just show you how that works. I'll just hit zoom here. Oop, didn't want that one to go the other way. I want to zoom out. There we go. Now, the reason I wanted to do that is because if I go over, so now these are 1s. If I go over 1, I was going up 1 the first one, up 2 the second one. Watch this one. Over 1, up 9. So the stretch factor is 9. And that's the way you can tell the stretch factor. Just go 1 right or 1 left and see how far you're going up or down. That'll tell you what this number is out in front, provided it's a nice integer value that we can read off our graph. All right, so let's get rid of those two, sorry. Get rid of that one, this one. And how do you think we could make this parabola open wider? I want you to think about that now. Let's zoom back in here a little bit. Zoom in. All right. Right now, this is up at 2, and it's at 4. I'd like the parabola that I generate to open wider, like this, which means I'd want this value to come down here. The last time what happened is it got stretched this way. We made it bigger. Well, if I make this y value smaller, shouldn't that bring it down here, which would then open my parabola out this way? So I want the y values to get smaller from this parabola to my next one. Let's see what happens if I put here y equals, let's suppose I go with half. 1/2, use your slash button that's below the question mark, so 1/2, it automatically goes to a fraction format, x, use your up cap, and look what happened. So the blue one is 1/2 x squared. It is wider. So how would I make it even wider? Make the fraction even smaller. So let's try another one just to reinforce to you. If I made this y equals, let's try 1/8. So 1/8 of x squared. And look at that, it's even wider because now, just to show you why that happened, if I look here at 2, it was originally at 4. Well, if I put a half in it, it made the y value half of what it used to be, which is why it's now at 2. If I put a 1/8 in front of it, it's going to take 1/8 of your y value. Well, 1/8 of 4 is a half. So now it's going through the y value a half. So it kind of pulled it down this way. And that's what made it open wider. So to recap that, to make it open wider, you'd want to put a fraction out in front. To make it open narrower, you'd want to put some other number. that's more than 1 out in front. That would make it narrower. To make it open down, you would want to put a negative out in front. And you can do a combination of those. So for example, let's just get rid of this one. I could put here y equals negative 3. I'm going to put negative 3x squared. So in your head saying, what's going to happen? Negative, it's going to flip it. The 3 is going to make it narrower. So it should open down, but be narrower than the original red graph, which was our base graph. Let's see what it looks like. There it is. If you look at this one, it turned over, and it is narrower than the base parabola because of the 3 out in front. So that's a combination of the negative's called a reflection, so we turned it over and reflected it, and the 3 was a stretch, which would make it narrower. Okay, so now we've got 2 more transformations that we're going to be concerned with in this course. And the other one is how do I take, so the next one, sorry, is how do I take this base parabola and move it left or right? Well, I'm going to show you what happens, or how you do that. So we're going to go here, y equals, you need to put a bracket, x, I'm going to put here plus, let's say, 3, close your bracket. Now, you have to put the squared back on, so I'm going to put the squared outside of that bracket. X plus 3 squared. So let's look at what happened. Often what happens is maybe the opposite of what you thought was going to happen. Because our brains are programmed, when they see a plus 3, like we did here, we think right. Positive right, negative left. So let's go over and say, oh, look, oh wait, that's not what happened. It actually went, the vertex, which was here, it went left 3. Well, let's see if that was just a fluke or coincidence. Let's put a couple more on here. So let's put in here y equals, so if you saw what just happened there, I now put here x plus 6, and then I square it. What do you think's going to happen? Well, based on what we see from the example above, it should go left 6 units from the original one. And there it is. In black is x plus 6, which is 6 units to the left of our base parabola. Well, it appears then to make it go left, you put a plus 6 in the brackets and you square it. What do you think would I have to do in order to make it move to the right? Well, we're pretty clever minds in the room, in the course. Let's have a look here. I think if we switch that to a minus, it'll go the other way. Switch this to a minus, it'll go the other way. So if we want it to move to the right, we have to put a subtract inside the bracket in here. If we want it to move to the left, we have to put a plus in here. So that one can be confusing. It can be the opposite of what your brain would maybe be programmed to think. Okay, that's called a horizontal translation. Moving it left or right, fancy term. Okay, last one I want to show you is how do I take a base quadratic and move it up or down? Let's get rid of this one. Okay, so I've got y equals, watch what happens. I'm going to go x squared, no brackets this time, so I'm just going to have x squared, and then I'm going to move it up 3 units, plus 3. Look what happened. So if you have the plus 3 after the squared, not in here with what's being squared, you put a plus 3, it moved up 3. Well, I think we could figure out then how to move it down. So if I want it to move down, I just go x squared, subtract. Let's say, well, something I can see on here. Let's go subtract 4. And there's your parabola moved down 4. Now you may say, oh, it looks wider. Did it get wider? It's just because you can see more of it. No, it did not. You say, well, how do you know it didn't? Let's look right here. Let's go over 2, up 4. Look at the original. Over 2, up 4. Same width. This one here, saying, oh, this one looks narrower. Well, let's go over 2 and see how far we go. So if I go over 2, sorry, that's only over 1. over 2 is here. And up 4, because I was at 3. I ended up at 7, halfway in between. So it is the exact same, even though they may be deceiving to look at. Nothing changed other than I took the parabola, moved it up, down. Okay, so that's the last of that's a vertical translation. That's how you move a graph up or down. So what we got to be able to do is put all of that together and identify what would happen to a parabola if, so I'm going to type in here y is equal to, I'm going to put a negative there, I'm going to put a 3 there, I'm going to put a bracket, x, let's put plus 4, squared to make it a quadratic. So right away you can see 2 things have happened, 3 things have happened. Number 1, the negative made it open down. The 3 made this narrow in together compared to this one. And the plus 4 has moved the vertex 4 units to the left. If I wanted to even go more sample, let's add the last translation. Let's make it go up 2 units. I could put a plus 2 there. So based on what I know now about transformations of quadratic functions, the negative made it open down. The 3 made it narrower than it normally is. That's called a stretch factor. This is called a reflection. The plus 4 moved it left 4. That's a horizontal translation. The plus 2 moved it up 2. These last ones here, if you look at them, they will always coincide with the numbers that you'll use to figure out your vertex. This vertex is at -4 and 2. So it's always going to be the opposite sign of this number. So if you see a plus 4 here, your vertex is going to be at -4. And then this number will coincide with the y-coordinate, so -4 and 2. Let's put one more on that same grid. So let's keep this one opening up. So we'll go y equals, let's make it open wider. So let's make it a fraction. So it's going to be, and I'm going to keep it positive so that it opens up. Let's go 1/5. Close your bracket. Oh, I don't want the bracket there. I want it in the numerator. So 1/5 bracket. Let's make it go right this time. Let's make it go right 3. So -3. That should move it right 3. Turn it into a quadratic, so make it squared. And then I want to move it, let's make it go down this time. So let's move it down 2. So if you look at this one, compared to the base parabola, it's wider. And again, you say, well, how do I know it's wider? Well, pick a unit. So let's say you're here, but you're at 3, which is your vertex. Remember what I said? It's the opposite. So -3, the x-coordinate's +3. You can see it show up there when I touch that. And the y-coordinate is -2, which is this number right here. So eventually, I'm just going to give you this. There's not going to be any picture with it. You're going to have to actually make the picture. And you're going to have to be able to identify the vertex. Now, your stretch factor, if it's only 1/5, all that means is this. If you go 1 unit to the right, you're only going to go up whatever that stretch factor is out in front. So it went over 1, up. Now, it's hard to tell that on here, but it's only up 1/5 of a block. Look at this one. This one, we had a stretch factor of 3, which means if I go over 1, now over 1 is 2 blocks, so over 1, down to where it hit there, which would be 1, 2, 3. There's your stretch factor. Over 1, down 3. That's why your stretch factor is 3. And the reason I'm going down is because of the negative. All right, so let's go back to our notes. And I have all of this summarized here. Jump ahead to the next slide. So this is what we're going to call vertex form. And we're going to use the generic variables. We're going to use A, H, and K. Well, the first thing we're going to identify here is the vertex is always H comma K. So notice here, if it's a -H, the vertex is +H. So it's always the opposite for that one. This one will stay the same. So K, it's plus K, it's plus K. So for example, if I have y equals 3x plus 7 squared minus 4, My vertex is opposite, same. There's your vertex. So it's really important that you can identify the vertex of your quadratic. So once it's in this form, it has to model this pattern, then it's going to be easy for us to pick out the vertex. It's also going to be fairly easy for us to identify which way it opens, how wide it opens, and then we'll use the vertex in terms of moving it left, right. So let's just make sure we can remember. I'm just going to quickly go through all these. You could take the notes down if you wanted to. They're also in your class notebooks. So if A, the number in front, is greater than 0, that means it's positive. It's going to open up. If that number is less than 0, negative, it's going to open down. We looked at that in Desmos when we had the app opened up. If the absolute value of A, remember A is the number in front, is more than 1, absolute value just means ignore the negative. So just the magnitude, the value of the number out in front, ignoring the negative. So for example, if this was -3, when I go to look at the absolute value of A, it's just 3. Ignore the negative. We'll talk more about absolute value later in the course. So if that number is more than 1, your parabola is going to get narrower. If it's 1, it's going to stay the exact same way it was. If it's somewhere between 0 and 1, meaning it's a fraction that's less than 1, it's going to make your parabola open wider, which we looked at. If I have the h now we're going to look at, if h is greater than 0, then this graph is going to move to the right. Now, that means, remember, I'm just looking at the h only, this number. If it's x minus some number, so if it was x minus 4, in brackets squared, that's going right 4. If it's x plus 4 squared, it's going left 4. And of course, if there was nothing here, if it was just x squared, no number, it would stay, wouldn't move left or right. And the k value, we said if it's a plus k, it moves up. If it's a minus k, it moves down. Exactly what our brain would think. That's why it says here exactly the same. So if k is greater than 0, it's going to move up k units. If k is equal to 0, it doesn't move up or down, obviously. If k is less than 0, it's going to move the graph down. So when I summarize all of that, here's your vertex form. So the A is going to control whether it opens up or down and how wide it opens. The H and the K is going to give you the X coordinate of your vertex, and the K is going to give you the Y coordinate of your vertex. And the H is left-right movement, and the K is up-down movement. Other things I'm going to ask you to find about quadratics, I'm going to ask you for the intercepts, sometimes also called the zeros. Well, the x-intercepts, I'm sure you're familiar with, I hope you are anyway. There's a parabola. These numbers right here would be the x-intercepts. Well, the nice things about those numbers, when you go to find them, is that the y value has to be 0. The y value, whatever it is over here, has to be 0. So that's how we find the x-intercepts. We just make the y value equal to 0. Now, we'll do a lot more of that later on in the course, not so much right here in the beginning. We will do the y-intercept, because this one's a little bit tougher, because if you put 0 over here and you're dealing with a quadratic, you have to have some strategies to solve a quadratic equation, which we haven't looked at yet. That's coming later. This one here, y-intercept, so for example, this point right here, well, what's special about the y-intercept is that x is always 0. So to find the y-intercept of any graph, doesn't matter whether it's a quadratic or a line or what shape it is, that's how you find it. You fill 0 in for the x. The domain is asking you what x values can your parabola take on. Now, nice thing is, it's almost always x can be anything, because on a parabola, here's your x scale. Well, it doesn't matter what number I pick, it's going to be somewhere on the parabola. If I pick one way out here, it's eventually going to hit it up there. So every single x value is usually on these parabolas that open up or down. The range will depend upon the vertex and which way it opens up or down. It says right here. Because, for example, this graph over here, it doesn't hit, not every y value is going to be on that graph. If you had a y value down here, and I said, where's this on the parabola? Oh, well, it's not on the parabola. Correct, it's not. So the y values are all either above or below the y value at the vertex. Depends on whether they open up or down, which leads us into maximum and minimum value. So if a parabola or a quadratic function like this one over here opens up, I think you'd agree that the vertex is the lowest point on the graph. So if it opens up, we're dealing with a minimum value. If it opens down this way, like this one does, opens down, well then we've got a maximum situation. Now, when you're asked for the maximum or the minimum value, what we're looking for is the y value at the vertex. It's not an ordered pair. So it says down here, caution. The minimum or maximum is the y value at the vertex. It's not the ordered pair that represents the vertex. So for example, if I go over to this one, I say it is a minimum, and the minimum is y equals 1, 2, 3, 4, 5. Y equals -5. Just means that that's the lowest y value this graph ever takes on. And the reason you say, well, why is it just the y value? Because the x's don't have a minimum or maximum. I could keep picking bigger and bigger x values. They're going to hit the graph somewhere. Smaller and smaller x values, they're going to eventually hit the graph somewhere, but not our y values. So that's why we just use y equals to identify our maximum or our minimum value. And again, it's all dependent on whether it opens up or it opens down, which we now know how to identify. All right, let's move on to some practice. Do I understand all this stuff? So I'm going to start with a question that gives us a picture of the quadratic. So here's a picture of the quadratic, and we're just going to fill in this chart. This is a really common chart that I like to use to see if students can identify all the properties that I want them to know. So the first thing I want them to know is, well, what do I mean by the vertex? Well, hopefully you know it's this point right here. And I want the coordinates of it. So the vertex is at 1, 5. So this is going by 1s. Yes, it is. 6, 7, 8. 1, 8. There's your vertex. Always your x first, and then your y second. Remember the axis of symmetry. That's that vertical line that cuts your parabola down through the vertex. And it's always x equals, and it always is the x coordinate of your vertex. So in this case, it's going to be, if you just write 1 here, as I told you, I am not going to give you full value for that. It's x equals 1. Which direction does this parabola open? Well, hopefully that's easy. You just look at the picture. When the picture's there, it opens down. Stretch factor. I briefly explained that earlier. Let's go here to the vertex, go 1 unit left, and see what happens. So I go 1 unit left, down 2. 1 unit right, down 2. That's your stretch factor. That's how you tell. Over 1, down 2. Stretch factor, and it's never negative. Even if it opens down, your stretch factor is always a positive number. Make sure you remember that. Always positive. Guaranteed someone's going to put -2 there because it opens down, and again, you're going to lose probably a 0.5 or something. The x-intercepts. Look at the graph. Again, as long as you know what that term means, the x-intercepts are these two spots here where it crosses the x-axis. So they would be -1, 0, and the other one would be at 3, 0. There's your two x-intercepts. Your y-intercept, right here, it's crossing at y equals 6. So that's the ordered pair. X is 0 now, and the y coordinate is 6. Does this quadratic represent a maximum or a minimum? Well, because it opens down, it says to circle 1. This situation is a maximum. Then it says, well, what is the maximum or minimum value? It doesn't want to give away the answer. So this one, because it's a maximum, it's that number right there, so it will line up with 8. It's always the y value at your vertex. So it is, remember, it's not an ordered pair. It's y equals 8 in this case. the domain. What could x be on this graph? Well, we're going to assume, it doesn't have them on here, but we're going to assume that there was arrows that allowed this to keep going forever in that direction, which means this graph could eventually have any x value somewhere found on that graph. The last thing is the range. So the range is asking what y values are on this graph. Well, this graph is any y value that's below or equal to, because it actually hits there, the number 8. So the way you write that out is, so range, it's all y values that are less than or equal to the number 8. And I'll just make it a little bit more fancy. Tell people it's the real numbers. That means it's every single number, decimals, fractions, positives, negatives, whatever. Okay, there's your first example to show me you understand the properties of quadratic functions. So the next one is a little bit different. It doesn't give us the picture. It actually wants me to draw the picture at the very end. So I'm going to draw a sketch of this one at the very end after I fill in the chart. All right, so from this, remember the vertex, it always comes from here. There's your H and K. Your vertex is the opposite of this. So positive 1, positive 3. That's what I'm looking for here, 1, 3. Where's the axis of symmetry? Well, remember, it always cuts through the x-coordinate of the vertex. So it's x equals 1. Which way does this one open? There's a negative here. It opens down. What's the y-intercept? Well, I can't tell by looking at it, so I'm going to have to figure it out. To find that, you let x be 0. So you're going to fill 0 in where the x is. And then you're going to see what the answer is. So y would be negative 2, 0, take away 1 squared, and then add 3 and see what you get. Negative 1 and squared, you're going to get positive 1 times negative 2 is negative 2. Add 3, you're going to get 1. So the y-intercept is x is 0, y is 1. It opens down, so I have a maximum. What is the maximum? It's the y value at the vertex. So y is equal to 3. Domain, that's a freebie. It's almost always that. And the range. All the y values in this case, because it opens down, are going to be lower than the y value at the vertex. So all the y values are going to be smaller than or equal to 3. And now I'm going to draw a sketch of this. So the vertex is at 1, 3. And really all you need to do to draw sketches of these, there are a variety of ways you can do this, but I'm going to show you a nice, quick, easy way to do it. You just need to use the stretch factor and the vertex, whether it opens up or down. So I've got the vertex and the stretch factor. I'll just put here SF for stretch factor is 2. So I'm going to go over 1, up 3, 2, 3. There's my vertex, 1, 3. Now I'm going to use the stretch factor and make 2 points. The way you do that is you go left 1. Because it's opening down, go down 2. Put a dot. Go right 1. Scale down here. Right 1. Down 2. Then you're going to make a parabola through those points. So it'll often say show 3 key points. Well, here were the 3 key points. And you'd want to label these to show that you know how to use the stretch factor. So this point was 2, 1, and this point was 0, 1. So if you remember now, your axis of symmetry should have come down through here, which it would. X equals 1, left 1, down 2, right 1, down 2. All matches up with my stretch factor and whether that it's reflected to open down. All right, now one more. And this is an example of basically what you'd see if you were walking into a test or an exam question to see if you understand all this material. All right, here we go. So if you want to pause the video now and try it on your own, if you haven't done that already with some of these examples, certainly now would be a great time to do that, and then put it back on and see how you make it. All right, here are my solutions. So the vertex, opposite for the x, keep this one the same. Axis of symmetry is always x equals the x coordinate of your vertex because it cuts through the vertex. Which way does this one open? It's positive. This one's going to open up. What's the y-intercept? Well, we're going to fill 0 in for the x. So 0 plus 1 is 1. Squared is 1. Times 3 is 3. Take away 2 is 1. So the y-intercept is 0, 1. Max or min? So this time we said it opens up. If it opens up, this is the lowest point. So this time we've got a minimum. Well, what is the minimum? Remember, the max or the minimum is always the y value at the vertex. So it's y equals that number. That's the lowest number this graph ever reaches. The domain, x, could be any real number, and the range. So think about it now. All the y values, because it opens up, are going to be above the vertex. So all the y values are going to be bigger than or equal to -2. All right, so to sketch it, we're going to go -1, -2. There's your vertex. And then you're going to use your stretch factor. I think this time it's a 3. Yes, and it's opening up. So that means from the vertex, go over 1, up 3. Go left 1, up 3. And that's what we call symmetry. So that we go 1 to the right, up the same distance, 1 to the left, up the same distance. Now I'll try and connect those in a nice parabola. It's not easy to do with stylus here in the laptop, but best I can. So it said label 3 key points. So there's 1. I got this point over here, which was 0, 1. I had this point over here, which was -2, 1. Okay, so that is the end of our first section on the properties of quadratic functions. If you have any questions or concerns, reach out to me through email, and I'll try and get you pointed in the right direction. There will be a set of practice questions in your class notebook that you can find. Use those to make sure you understand the material in some depth. And once we get through that material, we'll move on to our next section. So best of luck with your practice questions.